Hey guys, welcome back to the channel Techbeast.org. So today I have come up with something more interesting for you guys, which is Redis. Okay, so Redis is quite popular among the cloud industries. Okay, so not just for IoT applications. So Redis is being used everywhere in the industries today. Okay, so when it comes to data caching, faster data access, okay, session management, so there are many applications Redis is ruling the industry. Okay, so in this video what we are going to see is it's basically an introduction video. Okay, so how you can use Redis for IoT applications, and there are multiple parts which I'm planning to release for this particular open source software, which is Redis. Okay, so in this video we are going to set up and install the Redis in a Raspberry Pi. Okay, so and we are going to execute some basic commands. Okay, so before we jump into how you can use the IoT sensors to store it in Redis. Okay, so to use Redis as a message broker, to use Redis as a real-time streaming pipeline. Okay, so to store Redis as a data storing option. Okay, so for such applications we will see in our next video. So this particular video, I'm going to give you an introduction. We are going to install Redis in our Raspberry Pi, and we are going to run some commands by getting our hands dirty. Okay, so let's jump into the session. So what is Redis? So Redis stands for Remote Dictionary Server. Okay, so the name itself says, okay, REDIS, so which is a remote dictionary server. Okay, so it's an open source in-memory data store. Primarily stores data in RAM, in your random access memory. Okay, so in your system's RAM, the data will be stored. Okay, so due to this nature, okay, Redis is much faster than any other traditional NoSQL database and other SQL databases. Okay, so which basically stores the data in your hard disk. Okay, so definitely there is going to be some latency when it comes to read and write. Okay, so it's considered as a NoSQL database, primarily uses a key value data model. Okay, so other than tabular relations like traditional SQL. So in your traditional SQL, we are going to write some SQL queries. For example, select everything from my table. Okay, so you can join table 1 and table 2. Okay, so and extract the information you want. Okay, so we are not going to do such complex SQL queries here. Since it is a NoSQL database, all your data will be stored in a key value data model. Okay, so it offers low latency and read and write. As I already mentioned, since Redis stores all the data in RAM, okay, so it can able to offer low latency read and writes. Okay, so Redis is mainly used for caching purposes like database query caching, session management, etc. Okay, so as I mentioned, database query caching, for example, you have a huge SQL database with billions of parameters. Okay, and you want to query some few million rows or few thousand rows. Just assume. Okay, so in this case, if you're every time you're making a query to your SQL server, there are so much of read and write operation. Okay, IO operations being happening. Okay, on your database. Okay, so in this case, let's say there are frequent queries. If you are using, you can use Redis for caching purpose, and this will help to increase the speed of your query. Okay, so this is how Redis is being used in industries nowadays. And of course, as I mentioned, session management. Okay, so you are logging into a particular web application or any of your IoT applications, which basically manages a session. Okay, so the session login and session logout, okay, all those things we can use Redis to manage it. Okay, so it can be used as a message broker. Okay, and also for real-time data ingestion and processing. Okay, so this one we will take a look at it in our upcoming videos. Okay, so as a hands-on, mostly for IoT applications. Okay, so these are some applications of Redis. So real-time IoT data processing, caching and fast data access, message queuing. Okay, so due to its nature of incremental and decremental functionalities, by default, it's available in Redis, and as a result, message queuing is one of the very good use case we can use Redis. Okay, use for. Of course, session management is another use case we mentioned. Then geolocation services. Okay, so for example, let's take from IoT perspective. Okay, so today there is a Helium network which has a lot of LoRaWAN gateways around your city. Okay, so all these gateway locations, we need to have a latitude and longitude informations. Okay, so for such services, we can use Redis because of its option to provide the geolocation data type itself. Okay, so Redis supports geolocation data type where you can save your geolocation information. Okay, so to query and use it for your applications. For example, in my location, can you show me list down the number of gateways around me within X meters? Okay, and for such use cases, you can use Redis, and it can able to provide you with the details and other related info. Okay, so let's continue. So the next is very important, which is the data types. Okay, in Redis Community Edition, of course, Redis Enterprise Edition supports a bit more, which is more like a JSON data type and other data types. So since we talk a lot about open source software, here I'm going to cover the Redis Community Edition, and of course, in our hands-on, we are going to use Redis Community Edition as well. So okay, so first data type is string, which is a very basic data type. Okay, so we all know what is a string. So for example, Techbeast, it's just a word. Okay, so we can call it a string. So string is a very basic data type. Okay, so you can store your key value pair in your Redis. Okay, as a string. So it's a very basic data type. So then followed by hash. Okay, so hash is basically a collection of key value pair. So you can assume it like a JSON dictionaries. Okay, you can assume it like a dictionary if you're doing programming, and if you're well versed with data types, so you know what is a dictionary. Okay, so it's basically a collection of some objects inside. Okay, so you can assume it like a collection of key value pair. We call it hashes. Okay, so for example, let's say you have a sensor, you have a sensor which is like a which is going to measure temperature, pressure, humidity, light. Okay, so all these are multiple properties tied to a single key, which is your sensor name. So for such applications, right, so we can use hash data type. So this is one of the key data type we will explore in this video. Okay, and it's mainly used for IoT applications. It's really useful. So next, followed by list. So list is basically a collection or list of strings sorted by the insertion order. Okay, so 0, 1, 2, 3, whatever the order you are inserting, the list will be sorted out. Okay, so set. So set is similar to list, but without duplicates. So okay, set, all the values in the set will be unique. Okay, so that is the key differentiation between the list and set. Of course, in set there is a sorted set, which is basically a collection or list of unique strings maintaining the order. Okay, the name itself say it's sorted, so which is ascending or descending. So maintaining an order, we can have a collection or list of unique strings. Okay, so stream is very useful, especially for our IoT use case. So its data structure acts like a append only logs. For example, append only logs we all know. So okay, when you're working on a Linux machines or something, okay, so you can check all the logs under your /var log folder. Okay, so where all your services and your applications will be just appending the logs on a file. Okay, so which is just keep on adding the logs on X interval. For example, 5 o'clock, 5 o'clock 1 minute, 5 o'clock 2 minutes, 5 o'clock 3 minutes. Okay, all these time interval based logs will be keep on appending to your system. Okay, so this stream is something similar. It behaves in a similar way. Okay, so basically it's a data structure, acts like an append only log. Okay, so basically we can use it to send the data to different clients. Okay, so for processing for different use cases. Okay, so we will take a look at it a bit later. Okay, so in depth we will see how you can use streams for your IoT applications, and how you can write clients to read those streams and process it for your IoT use case. So of course, bitmap. So this performs bitwise operation on string, then followed by bit field, which encodes multiple counters and string value. Okay, and followed by geospatial data, as I already mentioned earlier, to store coordinates and search for it. Okay, so these are all some of the key data types which Redis Community Edition supports. But in this video, what I'm going to focus more is about string, hash, and stream. Okay, so these are the widely used data types, I would say, for IoT use case. So basically, this is how you interact with Redis. Okay, it's just a simple diagram to show how the Redis works. So basically, we have two things. One is Redis server, which run all the Redis commands, all your logics, commands. Okay, everything will be running inside Redis server, and we need a gateway to connect to the Redis server and to get the response. Okay, so for that purpose, we will use a Redis client. So this Redis client, the sole purpose is just to interact with the server. Okay, it acts like a gateway, and via this Redis client, we will interact with the Redis server. So this it's something interesting I want to share with you guys. It's a memory footprint of Redis. Okay, so today in for IoT applications, okay, so we are talking about different sensors. Okay, so different sensors, different gateways, different loggers, Raspberry Pi Zero. Okay, so all these have very low amount of storage and very low amount of RAM and memory. Okay, so how can we use such devices to store our data efficiently and process our data efficiently? Okay, so for such purpose I think Redis is the solution. So that's why I really want to share this insights with you guys. So basically the memory footprint of Redis is discussed here. So in this experiment done by the Redis team, they have used 64-bit instances, and the following results were obtained. Okay, when you install a Redis server and client, an empty instant, it just uses 3 MB of memory, okay, of your RAM. So which is basically nothing. It's very small amount. And a 1 million small keys, okay, and string value pair, it uses 85 MB of your memory. And 1 million keys, which is like a hash value representing an object with 5 field. For example, you have a sensor, okay, so which have a sensor, it is measuring some parameters like temperature, humidity, pressure, light, and some accelerations. Okay, let's just assume. So it's let's say this 5 fields, it just uses 160 MB of memory for 1 million keys. Okay, so it's pretty impressive, right? So Redis, so this is the reason we can use Redis for very small memory gateways or devices, or even your Raspberry Pis. Okay, so now Raspberry Pi has even come up with 8 gig of RAM. Okay, so if you're using Raspberry Pi Zero, I think even Redis you can able to install it on Raspberry Pi Zero and make use of it for your specific IoT application. Okay, so string, hash map, and streams. Okay, so these are the three data types which we are going to see in this particular video in depth. Okay, so in our demo here, we will learn more about hash maps and streams and string for IoT applications. So as I mentioned, strings are basic data types to use for any IoT application. Then hash maps are better choice for IoT when you want to store multiple properties from a sensor. This is why I'm going to discuss more about hash maps. Okay, so in IoT industries, it's all about sensor data, timestamp, its values, and all those things. We are measuring from different machines, smart factory data, smart industries data, then your smart home data. Okay, everything has a property. Okay, so when you have such type of information and data, I think hash maps are the better choice. So of course, streams are better choice when you want to send data to different clients. Okay, from client A to client B. Okay, I'm going to send my data in real time, and client B will process it, maybe do some aggregation, do some filtering. Okay, so based on your logic, you can consume the streams. Okay, so these are all the things we are going to do in this short course. Okay, I would say. So, so this is okay. Now let's go ahead. So let's install Redis on our Raspberry Pi. So in my case, I have installed Ubuntu in my Raspberry Pi. Okay. So here you can just go to this Redis document. It is pretty clear. So what you can do to install. So basically, all you need is just update your sudo apt-get update, and to make sure all your binaries and your dependencies are up to date. Okay, for your OS. Then you can just install Redis by typing the command sudo apt-get install Redis. Okay, so this will start the installation. Okay, and it will restart at boot time. Okay, so this is how the installation you can continue on your Raspberry Pi. Okay, so which I'll show you just in a while. Okay, so it's time to get our hands dirty with some basic commands. Okay, so now let's install Redis in our Raspberry Pi. So I'm gonna log into my Raspberry Pi. In my case, I have used Ubuntu as my operating system for my Raspberry Pi. So for you, it can be Debian or any of the Raspberry Pi OS as per your choice. Okay, so now we are inside Raspberry Pi, and first step is always to update the Raspberry Pi with the latest packages. Okay, so sudo apt-get update. So let's wait for the update to be completed. Okay, so this will make sure that all the dependencies, packages, and everything is up to date for your Raspberry Pi OS. So this will take a little bit of time. So basically what we are going to do, once finish this update, we will install Redis in our Raspberry Pi. So the command is pretty straightforward. It's sudo apt get install Redis. Okay, so now you can see Redis is being installed. So now we have to wait for a while until the installation is completed. So it's asking 3804 KB of additional disk space will be used, which is around 3 MB. So I don't mind. So we can just install it. Okay, so let's wait for a while until the installation is finished. So now the installation has been completed. Okay, so now you can check the Redis service by typing command sudo systemctl status Redis. Okay, so this will show that Redis service is running. Okay, so now that we have installed Redis successfully in our Raspberry Pi, okay, so the first command you need to do is connect to the server using the client. So all you need to do is just type redis-cli. Okay, so this will make sure that the Redis it's connected to the server. Okay, so you can see that 6379 is the port number where our Redis is running. So you can just type ping to verify that the client and server is talking properly. So you can see when you type ping, the server will respond with pong. So this will make sure that you are we have successfully set up the client and server properly. Okay, so now let's continue to add some data to the Redis. So as I mentioned, we are going to look into like strings, hashes, and streams, okay, as our key data types. Okay, so first, the basic command is all you need to do is just type set. So in my case, I'm going to show you guys how you can set some temperature value in your Redis database. So I just type temperature, set temperature 23.5. Okay, so the Redis will respond. So the temperature value is already inserted into our Redis. Okay, so this is a very basic command and the data is stored. Okay, so the you can see the response is okay. So the good thing in Redis is there is no such thing like half of your data is stored in Redis. There is no such thing. So your data will be completely stored or the storing won't be there. Okay, so or your data won't be there. So this is just like a transaction you can imagine. So when you transfer money to someone or to your friend, okay, so there is no such thing like when you transfer $100, only $80 are reached to your friend and $20 is gone somewhere. It's not possible, right? So the Redis also is similar. So okay, so you can trust the data when it is stored in Redis, definitely it will be available. Okay, so that's how the Redis is reliable. Okay, so these are some simple command we can start with. So in order to access this data and the field, you can just type get temperature. Okay, so get temperature. Okay, so you can see the value is 23.5. Whatever we have inserted, we can able to access it. Okay, so this is very basic command. So now let me show you guys how you can use hashes. Okay, so in order to use hash, all you need to do is just type hash set. Okay, hash stands for hashes. Set is similar to what we used earlier. So you can see when we type hash set, Redis is suggesting us the command to insert. So in my case, the key I'm gonna use is sensor one. Okay, so in my sensor one, let's say there are multiple fields. Okay, just assume this is one. It's a sensor installed in my home, which is measuring so many parameters. Okay, so here I'm going to my first field is temperature, which is 23.5. My second field is humidity. Okay, so which is 70, I would say. Then followed by humidity 75. Okay, so then let me set headset sensor 1 CO2, which is 0.5. Okay, so now we have inserted all these values into our Redis. So now in order to access the hashes, all you need to do is just type get and your key is sensor 1. So just type temperature, you'll see 23.5 we are getting, and when you type humidity, you can see the value 75 we have got because we have overwritten 70, I think. Yeah. So now to access CO2, you can just type CO2, you can see 0.5. Okay, so these are all the values we have inserted into the Redis by using the hash data type. Okay, so like this, you can design your schema. For example, you have a machine and you want to monitor the machine for multiple parameters. Okay, so you can use hashes and you can design your data type similarly. Okay, so let me clear this, and the last one I can show you guys is how to do the stream. Okay, so in order to add a stream, all you need to do is just type x add. Okay, and your key is my first IoT stream, and my ID I can give as one. For example, your ID can be anything. It can be your timestamp or it can be any of your sequential number. Okay, so my field I'm going to use is temperature, which is a common string, which is a common data we use in IoT examples. So my first value is 23.5. Okay, then my second value is 23.7. Then my third value is 23.9. Okay, then my fourth value is 24. Okay, now we have created a stream with 4 values in it. Okay, so now we can access the stream by using the command xread. Okay, so you can specify the count. So in my case, the count is 2. Okay, then I'm going to give my stream name, which is my first IoT stream. Okay, and my ID I can just give 1. Okay, so you can see when I type 1, it's just giving me the value, the count of 2. Okay, so the first value is 2 to 3. If you give 0, it will give you the value from first and second. Okay, so if I change the count to 4, it will give you all the values. Okay, so this is how you can access the streams. So if you want to get a range of streams, it's pretty easy. So you can just type x range. Your key is my first IoT stream, and your start and end you can just give minus to plus, which is basically it will read everything. Okay, so you don't need to specify any count or something. You can see all the values available in your stream has been read here. Okay, so this is how Redis we can use streams for our IoT use cases. Definitely, of course, I will show you guys more. So we are directly using the command here. So in my upcoming videos, we will be using Python, and that will be more interesting, and you can use those code to integrate with your applications. Okay, so let's just clear this. So now the last one I'm going to show you guys is a simple pub/sub using Redis. So we can just, I can split the vein vertically here, and let me just log into my Raspberry Pi once again, because I'm going to publish and show you guys the subscription again. Okay, so in order to do the pub/sub, all we need to do is just type publish. Okay, when you type publish, you can see the channel and the message. So the channel name is, you can say sensor1 temp. Okay, or we can just say sensor1 temp. So the message here is my data 23.4. Okay, so here I'm going to connect to the Redis client again. Okay, so all I'm going to do is subscribe the channel, which is sensor1-temp. Okay, so now let me just publish the data. Okay, so you can see it's 23.4. So we have published the data and we have subscribed the data here. So let me just publish 25.2, and you can see the data is being subscribed here. Okay, so this is a simple pub/sub in Redis. Okay, so the difference between the streams and the pub/sub is stream will store the data. Okay, so the stream, the data will be persisted. Okay, but in pub/sub it's just fire and forget. Okay, so the data will be published. Once it is read by the subscriber, it's gone. Okay, so this is how the behavior of the Redis. Okay, so I hope you guys have learned some basic commands in Redis, and looking forward for my next video. Okay, so I'll show you guys more in a real world application in my upcoming video. Thanks for watching, guys. Let's make technology easy peasy for everyone. In case if you have missed to subscribe to my channel, please do subscribe and support me. Okay, so I'll see you with more interesting contents on IoT, cloud, and open source softwares. Okay, thank you very much.